Good.
Okay, great. So this is a status update for Stabilize, and I added the subtitle Hopes and Dreams because the nature of this status update is where we hope we can take this proposal, this set of issues that this proposal is about, but we don't know yet if it's possible. So I just wanted to explain where we'd like to go and hopefully get feedback from people both about whether it is possible and if it is, whether this direction is attractive, how people feel about this direction. So integrity traits are not something that that everyone knows well, so a little bit of recap. We've got right now 3 integrity traits in the language, usually referred to as integrity levels because they're in a linear hierarchy: frozen, sealed, and non-extensible. And on the left we have the verbs, in the middle we have the states, and on the right we have the predicates. And the thing that I'm taking as the defining characteristics of something being an integrity trait is that it's a monotonic one-way switch. Once frozen, always frozen. It's stronger object invariance. When an object is frozen, you have more guarantees that enable you to do higher integrity programming with less effort. It implicitly punches through proxies, or rather the integrity trait status is transparent through proxies. If the target has integrity trait X, then the proxy does, and vice versa. If the target is frozen, the proxy is frozen. If you try to freeze a proxy and the proxy allows the operation, then both the proxy and the target become frozen. Okay. In addition, there's a crucial distinction between explicit versus emergent, where there has to be 2 proxy traps per explicit integrity trait. So there's a prevent extensions and an is extensible proxy trap. There is no freeze or seal proxy trap because those are simply a pattern of other guarantees that either hold or do not. They're implied. So without going through all the detail I went through last time, I ended up with this taxonomy of all of the separate atomic unbundled integrity traits, each of which address some particular problem that can be addressed by integrity traits and that we believe are motivated. The important thing about this taxonomy in terms of the clarity of the unbundled thing is it allows us to go through them and see what we're talking about, what useful guarantees each of these provide. So fixed, it mitigates the return override mistake, the use of the return override mechanism in classes to stamp objects with private properties. If the object has been made fixed, if it has the integrity level fixed, then the idea would be that the use of the subclass constructor to stamp a private property on it would instead be rejected with an error. This is in particular motivated at Agoric for virtualization purposes, and there's a lot I can say about that if people are interested. And it's motivated in the shared structs working group, the structs and shared structs working group, because they want a fixed shape implementation of structs, and that conflicts with the way V8 implements the stamping of private fields. So fixed would address, they would make all structs fixed to so they could all benefit from a fixed shape implementation. So After the last presentation, we got this issue filed by Shu, which is V8 prefers normatively changing non-extensible to imply fixed. And we are, all the champions are overjoyed with this idea. This would separate it out from this proposal for new integrity traits. It would simply bundle it into non-extensible. V8, my understanding is already doing measurements to find out if it's feasible and is already getting some small number of negative results, but hold on, I'm getting a phone call. Hold on. Okay. Some small number of negative results. I don't know. We're hoping that the judgment is that we can still do that. Shu, let me just break process and ask you, do you have any information updates from the V8 measurements about whether you still hold out hope that we can do this?
I pasted the link in Matrix to the use counter. I can't believe it is not 0. It is AE minus 7 or something. So it is still more than I would like, but we don't really have a hard rule for like how small something has to be. I think this is few enough accesses that it'd be worth trying still, pending further data. Unfortunately, if you look at the slope of the graph, it is not flattened out yet. But this might be an artifact of just how the visualization is and how we're getting data, because it's been like a little bit less than a month since it's hit stable. So we're still getting more data as it hits a bigger population. Okay,
thank you. That's very clarifying, and it means that there's still hope, which is the most I was hoping for at this stage. Okay. Next is overridable to mitigate the return override mistake, which is well illustrated. I'm sorry, to mitigate the assignment override mistake, which is well illustrated by this sample code. If some prior piece of code freezes object prototype, then there are many old libraries, especially those written before classes, that do things like use a function to create what is effectively a class point, and then assign to the toString property of point prototype in order to override the toString method. If object prototype had already been naively frozen, then this will throw. And this has turned out to be the biggest deterrent for high integrity programming in JavaScript, the biggest deterrent for freezing all of the intrinsics. If there were an overridable integrity trait, then by making the prototype objects in particular, but all of the primordial intrinsics and others overridable, then the deterrent would go away and these assignments would work. And there's been controversy about whether to call this a mistake. And I just want to point out that in all of the years that we've been going around this, we have found code that breaks if this is fixed globally for the language, which I'll get into in a moment, but that is for an accidental reason. We have never encountered code that makes use of this aspect of the language on purpose. Let that sink in. After the last presentation, we got this issue filed by Justin Ridgewell clarifying what the history was on the prior attempt, and there was only one breakage observed, and it was very narrow. It was in an old version of the Lodash library, and even though it's already fixed in modern Lodash, we can never erase old versions from the web. And it had to do with the toString and the toString tag, I think specifically on typed arrays, even though it could apply in theory to other toStrings that depend on a toString tag behavior among the primitives. Justin, if you're within earshot, please correct anything that I'm getting wrong here. But what Justin is proposing is that it's still feasible to fix this globally for the language by having the global fix make a cutout specifically for the toString and toString tag properties that cause the old version of Lodash to go astray. And the cutouts that Justin Ridgewell is proposing, and the similar but somewhat different cutout that Richard Gibson has proposed, both of which have all the safety properties we need. It's just a little bit of ugliness, but it would let us fix this globally in the language. We would love that. We would be overjoyed if that could happen rather than addressing it through an integrity trait. Then there's the non-trapping, which is another reentrancy hazard problem. This is reentrancy through proxies. When you have a proxy that looks like a plain data object and survives all the tests that you might think to apply to it as to whether it is a plain data object, it might still be a proxy that does things synchronously during the handler traps. So you would like to be able to write code like this. And I want to recall our records and tuples, which is a presentation that is coming up later this meeting. Records are something that you could test whether something was a record or a tuple. If it is a record or a tuple, you knew it had no behavior. It was a plain data object. It could not be a proxy. So it would be very nice to, so that we could have tested that in an early input validation check, such that once you've passed the input validation check, you can then use the validated to be plain data objects inside your function while invariants are suspended, knowing that you're not going to be turning over controls synchronously to any foreign code. We don't have records and tuples, so what we'd like is to be able to create a predicate that we call record-like, but because there's no way to write a predicate today that will verify something is not a proxy, you can't actually write such a predicate that protects you from reentrancy. The idea is that by applying the new integrity traits, stabilize or non-trapping, and then having the record-like predicate check that something is stable, then that verifies that even if it is a proxy, that proxy will never trap to its handler. And thereby, even if it's a proxy, you are now safe against reentrancy hazards. And we've done that without making it observable whether it is a proxy or not. So this approach to the reentrancy hazard of handler traps does not violate proxy transparency. It just makes the existence of proxies that claim to be stable harmless because we now have a guarantee that they cannot reenter. At Agoric, we've actually have a shim. I believe that's a fairly complete shim for the non-trapping integrity trait by itself. It was actually kind of a surprise once we thought about it that it was possible to shim this faithfully and safely within the language, but it is. But it has one of these big have to run first burdens, which is it does it by replacing the global proxy constructor, and it only has the safety properties it claims if it has replaced it globally and the adversary cannot recover a normal proxy constructor by other means, such as by creating another realm. So it's quite burdensome to maintain the safety, but it is possible to shim it. And not only have we shimmed it, we now have a bunch of code that makes use of the shim as it was intended, for the safety that we intend. It's been an interesting learning experience to see how to use it for the safety we intend, and how much disruption there is to other code that's concerned with these properties. For code that is not concerned with this safety property, there should be no burden at all, because there's nothing otherwise is a compatibility break. Okay. Finally, there's the unbundling of non-extensible into permanent inheritance, which both the browser window proxy has without being non-extensible, and object prototype has without being non-extensible, is through magic they refuse to have their prototype be changed. And then with that taken care of by one side of the unbundling, the remaining unbundling from a non-extensible would be no new properties. So you could imagine two separate explicit integrity traits such that prevent extensions or non-extensible becomes emergent from those two new explicit ones. Okay, so having recapped all of that, what we're hoping for is, first, all of the champions of Stabilize and Shu, and Shu, I know you're on the call, so please correct me if I'm mischaracterizing anything. We all are of the opinion that even though there's a nice orthogonality from a language purist design point of view in unbundling non-extensible, and it allows us to retroactively rationalize this behavior of window proxy and object prototype, it's just not worth it practically. So we hope not to unbundle non-extensible, leave those two properties bundled into non-extensible. Non-extensible goes back to being explicit, and the result is that we cannot faithfully emulate the browser global object or the object prototype object, and we're willing to sacrifice that faithful emulation, even though it's a compromise of virtualization, because practically nobody will care. So first of all, Shu, did I characterize what we agree on there correctly?
Yes, we also prefer that non-extensibility remain bundled.
Great, thank you. Then the next one is the one that we've already mentioned, that Shu expresses in that filed issue, and that we talked about that with the current usage counters we still hope to do, which is also to bundle fixed into non-extensible, so there is no separate fixed integrity trait. Okay, then overridable, we're hoping that Justin Ridgewell's strategy with either Justin's carve-out or with Richard's alternate carve-out, we're hoping that that will enable us to go back and just fix it globally for the language without breaking the one case we know about in Lodash. So that goes away. And now all we're left with is non-trapping. So non-trapping would end up just getting bundled into stable, and now stable becomes explicit. So this is the picture we're hoping for, having taken care of the others by either choosing not to unbundle or by dealing with them by other means. And I want to acknowledge a political reality that is just there, which is somewhat unpleasant for us to realize, us the champions of the proposal, which is with the remaining, if our hoped for resolution happens, then stable addressing the reentrancy is addressing something much narrower than the original overall stabilized proposal, and therefore there's less wins in its sales. We understand that. We understand it will be more of an uphill climb to advance this through the stages and get consensus. But it's the right thing to do, so we're taking that hit and hoping that the others can move forward by themselves. I want to take a moment for a little bit of historic context. In 2010, 15 years ago, geez, Brendan did this presentation with input from myself and Tom Van Cutsem called Proxies Are Awesome, in which he presented what were our plans at the time for a non-trapping behavior of proxies. So just flipping through the slides here to the final transition. So this final transition going from trapping to fixed, notice that that in the fixed state, the handler, the blue circle above, gets dropped because the proxy will no longer trap to the handler, so there's not even any reason to continue to hold on to it. So the current non-trapping is very much in line with our original intention here, although certainly many of the details have changed over the 15 years since we first talked about non-trapping. So, and then one reason I brought that up is that if we get our hoped for picture, then we could also go back to the original name and call the non-trapping integrity trait fix, because it's nice and short, and something that's fixed is not broken. And at this point, I will take questions. Oh, I'm sorry. At this point, I will stop recording. And Rob?
Recording stopped.